So the next question that I gave those of you who were in on Friday is 2023 paper 1 question 4. So again, if you want to attempt this question before going back to this video to see the solution, please do so. So for this question, we're given a graph of a function g on the diagram below between -3 and 2. So our domain here is between -3 and 2. It says use the graph to answer parts A1 to A part 4. So the first thing we need to do is estimate the value of g of 1.5. Show your work on the graph. So g of 1.5, that means my input is 1.5. So my input is 1.5, we know my inputs are on the x-axis, so that's this point right here. So to estimate the value of g of 1.5, we need to go up or down until we meet the line. It's up in this question, and then we go directly across. You can see here it's roughly 2. So my estimate for that is going to be 2. G of 1.5 equals 2. Then the next part of the question is estimate the value of x for which g of x equals -6. So if g of x equals -6, that means my output is -6 and we need to find what my input is. So on the y-axis, we need to go out to -6 here. And we need to go across to until we meet the line, and that'll help us find what my input was. So we go out to the line and then we go up. And we see it's just less than 3, so I'm going to call that -2.8. It's important we have the minus there because this is -3, it's close to -3, so we're going to call it -2.8. So that's all we have to do for those two questions. And then the last question is just saying, take one box to show how many real roots the function g of x has in this domain. Give a reason for your answers. So we know that a root is where the function is equal to 0, or in other words, where the function touches the x-axis. So if you look at this line is our function, and it only touches the x-axis at one point, which is right here. So if it only touches the x-axis at one point, that means it only has one real root. And our reason for that is it only touches the x-axis at one point. And if we go on to the next page, we see the next part of the question. So it's asking us, from the graph, estimate the coordinates of the local maximum point and the local minimum point of g of x as accurately as possible. So if we go back here, our local maximum point is going to be for this part of the graph, and we see what point here is the maximum. It's going to be roughly here, and we're going to call that roughly at x equals -1.5. And then my local minimum point is going to be when the graph is down this way. So that's going to be down here, and it's going to be roughly at, I don't know, x equals 0.25, we'll say. So we have our two x coordinates, so we need to get our y coordinates now. So at this point, we said x is -1.5, and the y coordinate is around -1. So my point there is -1.5, -1. Then my local minimum here, x equals around 0.25, and the minimum is around the y is around -3. So that point is going to be 0.25 -3. So my local minimum -1.5 -1, my maximum 0.25 -3. Sorry, I said those wrong. That's my local maximum, that's my local minimum. So you know what a maximum minimum point is, what a local maximum and a local minimum point is it just refers to part of the graph. So it's basically where the graph changes. So we see it's going up here, then it changes to go down, it's going down, and it changes to go up. So that's why this is my local maximum and this is my local minimum. I don't want you to worry about part B in this question because it is a calculus question which we haven't knocked on yet.